Alright, so in this video I want to talk about LLM training process with DPO. So DPO stands for Direct Preference Optimization. So if you remember in the last few videos in this YouTube channel, I talked about how we can use RLHF and how we can use or leverage the RLHF to align the LLM to the human preferences or to certain alignment criteria, right? So now in this video I want to talk about DPO, which is direct preference optimization, and that is kind of a process to bypass the reward model and use a much more simpler model in case of aligning the LLM to human preferences, right? So if I just give you a refresher, like this is what we talked about in the last two videos, reinforcement learning from human feedback. So we start with fine-tuning the model, and that we fine-tune using a large data set that spans across like more than 1 trillion tokens. Then we have like the high quality data where we kind of do the supervised fine tuning or the instruction fine tuning, and that the data set generally ranges from 10k to 100k, and we kind of get a instruction fine tune model. So once these two steps are done and we get an LLM, that LLM may not perform to several alignment criteria like harmfulness, helpfulness, toxicity. In those alignment criteria, LLM may not perform well. So what we do is we do the RLHF, where at first we kind of train a reward model using the preference data set, and using that reward model we train a reinforcement learning model, which is a proximal policy optimization, and then using that we kind of updates the weight of the SFT model, right? So this is kind of an overview of the RLHF process. Now this RLHF process is, if you can just visualize in this manner, so this is what we talked about in the last two videos. So we have two set of models. One is the trainable LLM, and another is a frozen set of model, where we kind of try to find out the best optimal policy, and that optimal policy we do not try to like deviate from the base instruction fine tune model. So this frozen LLM is kind of a reference to the already performing instruction fine tune model, and that we use as an reference point to train the instruction fine tune model, and we kind of use the KL divergence to kind of eliminate this huge policy updates when doing the PPO updates, right? Now this has certain challenges. So this reinforcement learning from human feedback has certain challenges. So few of the challenges are like, you need to gather data, which is kind of a preference data set, and you need to also train a reward model, right? Then all this process like training a reward model, then using a reinforcement learning proximal policy optimization, all this involves a huge expensive computational cost, and also this comes with a uh, complexity of tuning the parameters of the reinforcement learning algorithm, which is proximal policy optimization. So all these are kind of a drawback if we want to train LLM to align with the human feedback. Now our the aim of this video is to use a DPO to solve that problems of RLHF, right? So in case of DPO, direct preference optimization, we have the prompts which we call as X. Then we have YW and YL. So this YW is kind of the winning response or the preferred response for the prompt, and YL is kind of the dispreferred or the losing response of that particular prompt. And using a maximum likelihood algorithm, we trying to increase the probability of this YW instead of the YL, right? So DPO optimizes the policy using a binary cross entropy objective function and eliminates the need of reward model and the PPO model. So these two models now we don't need to train a reward model. We can just eliminate the reward model, and also the PPO model we can directly get the policy using this maximum likelihood. You can use a binary cross entropy objective function to directly optimize the LLM for the human preferences, right? So here also we kind of use the preference data set, and which will kind of determine what responses are preferred and what responses are not, right? So this DPO is also has an objective function. So this is kind of the derivation of this objective function. We have we similarly, in case of proximal policy optimization, we also have a reference policy which kind of controls the behavior of the LLM, that we call as PyRef, and the pi theta is the policy which we are trying to optimize. And this we try to do by aggregating over the preference data set, right? Then we use a logistic function, the log of logistic function, and then there is a maximum likelihood objective portion, right, where we kind of measure the shift in preferred completion, which is like pi theta by pi ref, and which is nothing but YW, or the preferred response given the X or the prompt. And also we have the pi ref, which is kind of the frozen model, where we also have the YW given the X. Similarly, we have also measured the shift in dispreferred completion, and as you can see, like first is the preferred completion, then minus the dispreferred completion, right? So we try to maximize the preferred responses and minimize the dispreferred completions, right? So this is the objective function which we use in case of DPO, or direct preference optimization. And if you remember, like in the last few videos we talked about, this is the objective function for PPO, right, where this RM is nothing but the reward model, and then we have the KL divergence part, where we kind of check the shift of the current policy updates to a reference policy update, which comes from the frozen LLM model, right? So with this, I hope you got an understanding what are the different things we are doing in case of DPO, and now how the data set looks like, right, for training a DPO. So here also we have the preferred data set, where we have the chosen response and also the rejected response for a particular prompt. And this is one of the data set which we will use in the next video, where we will try to train the Mistral 7B supervised fine-tune model, and that we will fine-tune using the DPO, right? So this Anthropic HHRLHF is one of the data set that we will use. So data set is basically has this format. It has a prompt, then it has a corresponding chosen response, and also a rejected response, right? So with this, we will use the maximum likelihood objective function to train the DPO and train the LLM and fine-tune the LLM to human preferences, right? So that's all I have for this video. So in the next video, I will talk about how you can do the hands-on part and how you can do the coding implementation. And using Mistral 7B, we will try to implement the DPO in terms of code, right? So I hope you got an initial understanding of DPO. So more concepts will be clear in the next video, where we will talk about the hands-on implementation. For your time, if you haven't subscribed this channel, please subscribe and share this content with your friends and colleagues. Thank you. See you in the next video.